Hello there. Today, I'm looking at a microscope. Now, I've actually been told that a lot of people get sent these for free to do a review on. Well, I bought it because I don't check my emails, apparently. But I needed this so that I could accomplish what I think is going to be a pretty cool and possibly world's first goal today. But I thought it might be fun to take a look at this microscope and review it for quality and features and all of that fun stuff. So today, we're gonna be cracking this thing open and taking a look at it. Now, my actual objective here is to look at a CED under this microscope. I'm not gonna look at this one. The one that I'm gonna look at is the one that I pulled out of my CED player that ended up being the movie True Grit. That disc was put inside of the machine and then somehow orphaned without the caddy tray in it, which effectively meant that it was trash. And when I removed it, it ended up getting damaged, and I'm never putting that disc back into the player. So I thought it would be fun the other day to take a look at it with a lesser microscope that I have, and there's something really cool on there that we can see, and I want to get a better shot of that so that I can publish it for the public domain to use, because I think it's going to be the first ever image of its kind. But we're also going to look at a ton of other kinds of media and different pieces of small scale things to get a feel for what this scope can do. So let's get it open and see what it looks like. This box really makes this seem like a child product, especially the parts where it talks about children using the thing. But it really seems like this is actually a good microscope. Now, I would say what it is. Let's see. It says Andonstar plastic digital ... 32 gig card. This is one of those, I guess, bunch of names products that gets rebadged. I don't know. I've been informed that this is actually a reasonable brand. Now, here is the actual version of this that I bought. It is the Andonstar. I believe I have the 246S here. And this should be I think a 1080p sensor with HDMI out for the microscope. And it comes with a stand, and the stand might be a problem for me today. But let's go ahead and just get it built and check it out. All right, so here is the main piece. So there's going to be the camera right here, and then the display. I guess the camera is gonna flip down. Yeah. So we have the camera, the display, and then the outputs, of which the HDMI port, which is one of the reasons why I bought this, is mini HDMI. Thanks, guys. At least it's not micro HDMI. Oh, it comes with a mini to full-size HDMI. Okay, cable. I'm glad to see at least that. All right, USB power supply. You know, I actually didn't think about what the power supply situation was going to be. I'm glad it's not batteries. All right, we've got a lot of grease lubrication on this slide. Holy moly. This is going to be the focus wheel guide thing. That's so much lubricant. Jeez. Oh, there's there's a USB port in it for these. Oh, that's hilarious. So this is a kind of USB hub too. Oh, that's hilarious. All right. Here's one of the reasons why I bought the particular model that I did. It comes with two objectives there, and then I think there's supposed to be a third. But I should have a 7 to 8 millimeter and a 3 to 4. There should be like a 12 millimeter as well. All right, a remote. Don't underestimate the value of a remote on something like this, because you don't want to bump things, okay? And a bunch of fasteners. Oh, there's gonna be a whole assembly montage on this. Okay, cool. Now, one thing I am concerned about, and may look into a solution for on this, is that we will have this here, and then this here, and that limits the depth that we can get into with the microscope itself. So if I just kind of pretend, put this on there, I guess it's gonna go about there. So we are limited to this amount of depth. I may come up with a way of having this free float. Probably not today, but I might have to come up with a suboptimal solution for it at some point here for one of my objectives. It claims in here video resolution 2880 by 2160 at 24 frames per second. I don't think that that's ever going to be useful, and I'm pretty sure it only does 1080p through HDMI. It claims it can record... Oh, it says it can do 120 frames per second of 720p. Is that actually going to be a 120 FPS display? Because that would be hilarious. All right, step one, plug. Okay. We pop this on and put a screw through it. How far in is the CED gonna go? Oh, sweet. It's gonna go in far enough. We're not gonna have to mess with it too much today. Okay, screws going to the bottom. Boom. They have screws that have a well or a captive, let's say, piece of silicone down in there. Is that silicone? It's a little harder, but it's still a piece of captive plastic in there to press against the tube instead of just biting into it. That's going to be much, much better in the long run. And it's the same with the part that holds the actual scope too. I am very happy to see that it's not just gonna bite into the metal the whole time. Oh, we gotta unscrew the lens. Oh, that's the other lens. It comes with it pre-installed. I think that's it. So we're not installing the slides. Okay, hold on. Where do we plug the control cable? So I think you can have power, or you can have power and like buttons and lights and stuff. Like you can power just this if you use this cable, but if you want all the lights, then you need to use this one. That is weird. All right, here we go. First off, for all the weirdos. Wait, why are there two? This isn't a screen protector. It's got a tab on it. I am very sure that is actually meant to be a screen protector. It's too tall. It doesn't fit. That is a screen protector. That's so weird. So the reason I bought this particular one was because it's HDMI. So let's see what HDMI looks like with it. Whoa, crazy. Look, it's a thing. All right. The video on the display is slightly covered by the plastic frame. You can see if I rotate this back, you can see the top of the camera reels, but if I rotate it forward, the plastic frame covers it. Does the menu show up on the capture? It does. Okay, I actually like that. I'm gonna disable my view here for the live stuff. Okay, so resolution. Okay, I don't, is that 60? I don't know. I'm not convinced that that is 60. All right, exposure, being able to control that's pretty sweet. Okay, I like that. All right, let's stick something under it. Here, just the manual. All right, there we are. Like instantly dots. Like, that's pretty good. I like the focus control. Oh, there's a freeze button on the remote, so I can do that and then remove this. So that's nice. So they have a bunch of things they suggest that you look at on this scope, and we are definitely gonna do that one. Oh wait, I do technically own one of these, and it may even be in the office now that I think about it. But no, and I'm not even counting ones that are in record players. No, I don't have any watches, and then jade identification, that's such a weird one. Anyway, we're gonna look at coins. Because I was looking at this, and I was like, what kind of weirdo collects coins? And I was like, wait a minute, that's me. All right, so we got some really important historical coins here, like the Chuck E. Cheese token. There we go, look at that, look at the mouse's face. Whoa, crazy. We could put the lights on this too, why not? One light, whoa. And we got another light, whoa. But you know what's even better than Chuck E. Cheese? Peter Piper Pizza, what's up? Oh, that one looks really good on here. Now, I think we can really crank this up and get closer and then refocus. I wanna mess with that. Whoa, we can. Okay, so that is a wide wide focus range. Holy moly. Anyway, let's look at some felonies. Here's some penguins from SeaWorld. Wow, that's interesting. So that's actually kind of cool. I was not expecting to see something in this that I thought was interesting. The coin gets pressed and stretched in a machine that's designed to destroy, federal currency. But what ends up happening is it is exposing the copper on top of there. So the corroded shadows are where the copper was worn thinner and exposed, and it doesn't have the coating as much on it protecting it. That's kind of cool to see. And then can't not have local Phoenix Zoo. What's up? This one much more evenly applied the pressure and stretched the whole coating. But I got no idea what lizard that's supposed to be. It just says Arizona. It's the Arizona lizard. That's what it is. All right, let's put the coins away. Okay, we're going to step this up a notch now. I mean, we're going to kick this up a notch now. Bam. That's right. It's not, it's counter, the counter rotate. Anyway, it's a wafer. We're going to look at a wafer on here. I do not know what the die is, but we can very, very clearly see it. So let's check this out. So this will be where, my God, that looks good. Holy moly. That's insane. Okay, I'm now very, very excited about the CED. Okay. Yeah, that's awesome. Don't forget to test the digital zoom. We can try that, actually. Let's see. How far in will it go? It says 3 times. I don't think I necessarily believe it, though, that it's doing this correctly. The aspect ratio of the image is changing as it zooms. So 1.0, let's pretend that's square. That's wider. That's taller. That's wider. That's the same. That's taller. So, yeah, we're not going to use that. Nope. Okay, I wasn't recording with the good quality camera and stuff, but I thought this was a lens case, and nope, that's not a lens case. Okay, all right, let's put the actual microscope lenses on. This part sucks installing this, by the way. I don't like this. Yeah, that's working. Okay, let's see what we can see with this. We were looking at this thing, we were trying to read something in the lower left, so let's see if this is legible here. It actually is lettering. All right, let's try the other lens for giggles. Okay, this lens sucks. Yeah, this is one of the reasons why I said I didn't buy the ridiculous magnification claims that they had. I don't think there's actually a benefit to using that lens. Yeah, it looks hazy because it's not a good lens. That's the thing. So that's center of focal range, and that's not really better. Actually, I don't think that this is better than the other one at all. There are some more things I want to check out. While we have super high level magnification on here, I want to look at a CD. I want to see if we can see the pits and lands on a CD. But before we do a CD, we should do a Laserdisc first, because those pits and lands are probably a lot bigger. So here we have the mind's eye on Laserdisc, and we're going to try and look at this. Now, this is something that I really care about, so I need to be very careful with this. So I can technically see something, but I don't know. There we go. Now we're getting some, yeah, we need a much brighter light from farther away to get actual stuff out of this. Okay, now this is awesome. Hold on. Yeah, it would depend. You know what? This might actually be a, yeah, this is a CAV disc. So actually, in theory, we might be able to see something. So you are now looking at this. The top is the outside edge. The bottom is the inside edge. Actually, I think this is a horizontal sync we're looking at. I don't know if I can focus this anymore. Let me try. Oh, the answer is yes. Oh my God. Look at that. That's crazy. Okay. Whoa. So to explain what it is we're looking at on this Laserdisc, let me get an overhead shot and try and show you the portions of this disc as they are laid out on here. So you can see the little squares over here. This is a CAV disc. Where is it labeled? There, right there, CAV. That stands for constant angular velocity. That means that as the disc rotates, the disc itself stays at the same RPM throughout the entire play session. The benefit to that is that they can put specific numbers of fields on each rotation of the disc. So as the disc continues to play, you can stop the movement of the read head into or out of the disc in one spot, and it can keep showing the exact same frame over and over again. Because the mind's eye is more of a visual feast, it's meant to be viewed and appreciated like that. So this is a CAV disc. So what we can see here, these individual squares are horizontal lines. Then the big section over here is a vertical blank period. So a CRT would be drawing horizontal lines one after another until it reaches this point. Then the raster beam would go from the bottom of the display back up to the top. And then here it would start drawing more lines again as it goes around. So what we are looking at on the microscope here is a horizontal blank mark. So that is what that bright stripe is in the middle. That is a horizontal blank. All the existing images of these, oh my gosh. I'm setting records in the thing that I'm not even trying to set records in. All right, fine. Apparently we should take a capture of this. So I'm gonna put the SD card in there, which is probably gonna mess up my focus. And then we'll try again here. You should be able to see the horizontal pulse and then the color burst. Maybe that's the color burst, actually. I don't know. Yeah, you can't see any obvious zones in a CLV. I probably have one in the other room, but a CAV is going to be far more interesting. Holy moly, that ended up sharper than I thought it could. All right, so before we skip over to a CD, I want to look at a CLV. Now, because this is CAV, we're seeing things like that horizontal line there. That is one of the H-sync pulses. We should not be able to see something like that on a CLV disc, but I'm curious if we will. So to give you an idea of what a CLV looks like in comparison here, if we look at the surface of the disc, we just see radial patterns with no repetition in the radius. We just see rings going in because everything is mixed up. Instead of spinning at a fixed speed along the edge, it spins at a fixed speed relative to the media. This allows them to fit more on the disc, but it makes it a little bit more difficult to pause and see things. So there's video lines on a Laserdisc. No big deal. Man, don't make me go looking through my Laserdisc to see if we could find one we could see something in. That's just mean. Well, that's the thing. Is that an H-sync pulse? Because that doesn't make sense. Unless it's more like zone bit recording on a floppy disk than it is like actually linear. Because it seems like it's happening in steps. All right, we'll take one more picture. And I think we're gonna move on to our next media sample now. Go back to Minds LD, see if you can find an image. Oh man, come on, why you gotta do this? There's no way we're gonna find an image. It's not gonna happen. It's not gonna happen. We're not gonna find an image. I found an image. Here's an image. Okay, I want to explain what it is we're looking at on these video formats where we can kind of see image data. So imagine you have your TV, okay, as this square box right here. Video data is sent to it as a continuous line over time, okay? At least in the time of CRTs when these would have been recorded. This line would be broken up into points that mark sync pulses. Some of these pulses are known as horizontal sync pulses or H pulses, and some of these are known as vertical sync pulses or V sync pulses. Horizontal pulse sections are a single line that are shown across the image. We then hit the horizontal pulse and the line wraps back rapidly and then starts drawing the next line on the display that has image data. So what you will actually see is not continuous image data. You will see a blank period where there is no image while it waits for the beam to get back over to the other side of the display. We see the exact same thing for vertical sync pulses, which are usually much longer than horizontal sync pulses. When we get to the very end of the display, the V-sync pulse will happen, and then the beam shoots back up to the top. Now, what we are looking at is a little weird and conceptually strange on these discs. Let's say I take this transparency sheet, okay, and I'm going to draw an image that has 4 lines on it. You know what? Let's just make it 3 because I happen to have 3 markers nearby. We have our red line here, and then we have our blue line right here, okay? Each one of these has an H-sync pulse that happens that sends the beam over to the next line, and then at the very end, there is the V-sync pulse that sends it back up to the top of the display. Now, what we can see on the discs is a little different. We can only see one window that represents a single line of our feed. And then over here, we would actually see the green line over there. And then we would see the blue line if we continued off over to the side even more. What this means is for each revolution of the disc, we see a different version of the red line. So the only way we can see a change in the red line that is actually meaningful is if the video image slides up as the film is shot. So the camera itself, the camera needs to pan down, which would make the image move up. That's the only way we can see something recognizable in the video signal. So we're hoping to find a panning shot where the camera moves down or the video content moves up. That's the only way we can see something meaningful in one of those blocks.
Oh my God. That is text on a laser disc. I think we can make this legible. You're saying musicians, that's what it says? Oh, it's upside down and backwards. You're right. Wait, so that's gonna be like second chair or something, isn't it? Oh my, that says keyboard. 100%. That says third line on the right, the first of the 2 words is keyboard. It's upside down, but that's 100% keyboard. Oh my God. Okay, this is more impressive than the CED. I'm sorry, I didn't think we would actually be able to see text on a friggin' laser disc. What? I need to find the spot for the flashlight that has the best contrast. Maybe the light needs to be more dead on. Oh, that's wild. No. When it's dead on, we just get one color at a time. Dude, laser discs are weird, man.
I should take a moment here to explain the rainbow effects because I didn't actually touch on this in my original live stream of this. On things like CDs and laserdiscs where you can see the rainbow iridescence, what you are actually seeing is a phenomenon known as diffraction grating. The wavelength of the light that is landing on the surface of the disc is being broken up and reflected back as different wavelengths. This happens because of the size of the grooves on the surface. Now, we don't need to get too deep into the physics of how this all works, but what I'm trying to do here is find a point where that refraction split happens on the video signal specifically. As we saw, when I go perpendicular to the lines on the disc, we get a direct refraction back of a single color. So I need to find a point along the side where the light can make it to the video data, but not completely be lost.
Or as I move to the side, we start to get gradients. And then boom. So I want it to be right there. The speed for the text just happened to work out per revolution of the media so that the text is actually text shape. Because like there's no reason this text shouldn't be like super duper tall or so short that it was unrecognizable.
Here's one final comparison between the actual end credit sequence of the mind's eye and the video signal that we can observe on the disc. This is just insane.
Yeah, all right, I'm gonna do that. Picture, done. We're gonna call it there, okay? Holy moly, that was crazy. After that oddly successful round with the Laserdisc, I really want to try the CED, but the CED has other complexities to it. I might even need to switch over
to the lower magnification one. I'm not 100% sure. You know what? Let's just stick it on there and take a peek and see what we can find. Now let's try to get a diffraction grading going on. I'm gonna run this towards the end. Wow. Look at that damage to the disc there. Or maybe that's an actual thing in the video. I don't know. I think that's damage to the disc, but I'm not sure. This is why the CED is never going in a player again. This thing is just beat up. Okay, hold on. Okay, there we go. That's looking more video-like. Yeah, that's what we want to see. Okay, I don't know how to tell which is side 1 and which is side 2, so that's fun. We're just gonna kind of have to wing it. Hope for the best. That looks kind of credits-like to me. Wait. Okay, well that's very definitely, oh my gosh, we just nailed it. Bang, right there. Job done. There's text on a CED. The end. Oh my gosh, it's so visible. That's insane. What? Good Lord. Horizontal flip. Wow. Oh yeah. Click. All right, well, I feel like that is the most success we could ever hope for on CED. So let's go ahead and take a look at a couple more things here that are not going to be as revolutionary, but just for kicks to see what we can see. Okay, we're going to try the Offspring Americana, which has an incredibly visible ring between the CD audio and the Blue Book section. So let's see what that looks like. Oh, that definitely is. Oh, now that is super cool. Yeah, there we go. So I think if I remember correctly with this disc, we have audio session, all right, and then we have a hybrid ISO 9660 and HFS Plus session. So it's possible that this could be, say, the ISO 9660 data or the HFS data that is distinct, and then the rest of it in this other section up here is the merged data. So these are probably the track leadouts or something to that effect. But yeah, that's a very visible difference there. Yeah, but the other thing I saw was that might be actually, maybe that's a track separator. Let's see if there's another one that's visible. Oh my gosh, those separate tracks. That's what they are. Okay, one bonus thing. Here's a CDRW. We can very visibly see tracks on that, I think. That's kind of cool. All right, I think maybe my last test here is going to be a mobile phone display. And I'm gonna let my live stream be what shows up on here. So this is the chat for my viewers who are watching me mess around with this stuff live. Now, chances are we're not actually going to see any text. I'm actually hoping to see subpixels, but we'll see what we get. It's interesting. So I didn't realize that my phone had the like little mini baby green pixels. So there is a first Twitch badge. So yeah, there's what a display looks like under there, at least a S24 Ultra's OLED. Well, I gotta say, the Andonstar here, whichever version it was I got, this is the, I believe, A246S. I'm pretty darn happy with it. I will be getting some photos on Wikipedia now based on the media samples that I took a look at here today using this thing. So, I mean, yeah, it's pretty hard to argue that it wasn't incredible. So I can only highly recommend this, and I guess I'll link it down below if you want one. That will be an affiliate link, by the way. I think I have to state that up front. Anyway, if you enjoyed this one, you may want to follow the channel. If you want to help support the channel, I am on Patreon. But for now, that's it, and I will see you next time.